Good morning, dear students. Myself, Vinod B, instructor, Department of Electronics and Communication Engineering, BGMIT Muthoda. Today, we shall continue the next program of your computer communication networking lab. Today, we shall see Dijkstra algorithm. Right? Basically, Dijkstra algorithm is a shortest path algorithm, or to find out the shortest path between source and destination, and this Dijkstra algorithm can be implemented for distance vector routing algorithm, or it can be implemented for protocol link state protocol, basically to find out the shortest path between source and destination, right? There is another program or another algorithm which is used for finding the shortest path, that is Bellman-Ford algorithm, right? But for your lab it is a Dijkstra algorithm, so we shall continue the Dijkstra algorithm, right? So this is the algorithm which is related to the Dijkstra, that is flowchart, right? Here you can see that uh, start of program, then we have to select an root, that is a root node in the topology given, then we keep on making an tentative list, then after making tentative list we update the tentative list, right? Then we make it as a permanent list, then this loop will be continuing until all the nodes are selected and the shortest path is selected from the root node to all the nodes in the network, right? So for working of this, let's select an example where you can see that in this example, uh, five nodes are considered, that is A, B, C, D, E, right? And each node is connected with the different nodes in the topology, and the weight for each path is given, right? Example, if you take the A is connected to B and the weightage of this link is 5, right? If you take A to C, then link is, the weightage of the link is 2. If you take the A to D, then link is, or weightage of the link is 3, right? Similarly, if you keep on taking this, or if you see that A is not connected to E, then we take it as infinity. The the weightage we consider it as infinity, right? Similarly, if you keep taking this example and we select A as an root node, right? From where we are, if root node is nothing but it is a source node from which we are uh, finding the paths to all the different nodes in the network, right? And that path is nothing but a shortest path, right? So example, if you take from A, we have direct connections to B, C and D, right? So you can see that move A to the permanent list and add B, C, D to the tentative list, right? B, C, D are direct contact, so we added it to the tentative list, right? And we can see that the weightage of each path, right? That is 5, 2 and 3, right? Now among that we will take the short, the weightage with less, right? So we move C to the permanent and add E to the list, because from C we have direct connection to the E, so C is moved to the permanent list and E is added to the tentative list. Now we have A as permanent and C as permanent, right? After that, move D to the permanent list, right? Instead of B we are adding D. The reason is that B is having less cost compared to B, so we add D, right? Now in the permanent list we have A, C and D, right? We don't have still B and E, they are in tentative list. Now we will move B to the permanent list, right? Now in the permanent list we have A, B, C, D and their weightages, right? Now we will find the path to the E, right? You can see in this diagram, you can see the path to E can be calculated A to B, B to E. If you take the path weightage, then it will be 8, right? If you take the path from A to C, then A to C to B, then C to E, then you can see that 2 plus 4 it is 6, 6 plus 3 it is 9, right? So if you consider all these probabilities, then the shortest path from A to E is from A to C, C to E, that is 2 plus 4 it is 6. Now we find the path from A to E, that is the shortest path. From 0 to 6 it is uh, a shortest path from A to E. Now keeping A as the local node or the source node or the root node, we have finded the shortest path to all the nodes using this Dijkstra algorithm, that is using tentative as well as permanent list, right? So tentative list is a temporary list where we keep on adding the direct links and we select the nodes which are having less weightage or the path which are having the less cost, right? Now we can see in the sixth diagram that A is having connection with B, connection with C, connection with D, and connection with E, right? So there is no direct connection between A and E, but C has been used as an intermediate node. So if we take the weightage of this, the total weightage from A to E is 6, right? So this is the example, and explanation for this example they have given here. We make a node A the root of the tree and move it to the tentative list, right? Then to A, B, C, D are connected and we take the weightages. Now we move C to the permanent list and still B and D are in the tentative list. Now we add E to the tentative list because E is directly connected to C. Now what we do? B, sorry, B, then D, then E are in the tentative list. Now I move D to the permanent list. Now the permanent list is expanding. You can see that this is D, right? And the cost is 3, right? Now in tentative list we are left with only B and E. Now we add B to this tentative list. So tentative list is A, B, C, D, and we are left with E. Now lastly we add this E. Now the routing table is available where you can see that A to A the cost is 0, right? So we don't require any intermediate nodes, that is next router. Now from A to B the cost is 5. Again we have direct link, we doesn't require any next router. A to C the cost is 2. A to D the cost is 3. Now A to E we have many multiple paths. Among that we have selected the next router path or intermediate node path C. So the cost is 6 because this cost is minimum compared to the other paths, right? So this is the brief explanation about Dijkstra algorithm. Dijkstra algorithm. Dijkstra algorithm. Now we shall see the program related to Dijkstra algorithm, right? So this is the C program written for the Dijkstra algorithm. Once you execute this, right, see, keeping same topology, right? So I have taken enter the number of vertices, that is number of nodes. Vertices is nothing but node. We take it as a 5. Then we enter the adjacent matrix. Adjacent matrix means for each vertices which are the vertices connected and what is the cost. Then if you to see this matrix, right, this is the adjacent matrix where from A to A it is 0, I have entered it as 0. A to B is 5, I have entered it as 5. A to C it is 2, I have entered it as 2. A to D it is as 3, and A to E basically we take it as we doesn't have any direct connection. We take it as an infinity, but it is written in our program as triple line. That is, we have taken the maximum cost as triple line. Right. Now similarly I will update all the adjacent matrix for this particular topology. Once I fill this adjacent matrix, then I take the starting path or the source node. I have selected the source node as A, that is written as 0. Now the path from A to node 1 is B, right? There is a direct path and it is written as, and value of this path is 5, right? So path is given from, that is A to B, that is 0 to 1, it is direct. Similarly for node 2, node 3, and if you take node 4, that is node 4 is nothing but E, right? So if you take this, then the distance is uh, 6 because we are taking from A to C, C to E, that is 2 plus 4, it is 6. You can see that 0, 2 and 4, right? So this is how the Dijkstra algorithm works, and it is shortest path algorithm which is used in most of routing protocol. We shall continue the execution of program of Dijkstra algorithm. Here I have pasted the program here. I am going to execute it. Once I execute, I will enter the number of vertices. Vertices means number of nodes. The number of nodes selected in this example are 5. So I will enter it here as 5. Once I enter it as 5, I will enter the cost matrix. Now the cost matrix for this is from A to A it is 0, then A to B it is 5, A to C it is 2, A to D it is 3, A to E we doesn't have direct connection, so we enter it as 999. We will update the entire matrix 0, 5, 2, 3, 999. Then next node, from node B to A it is 5, from node B to B it is 0, from B to C it is 4, B to D we doesn't have connection, so we take it as 999. But basically it is taken as an infinity, but in program we can't take infinity, so we take it as the highest value, that is 999. 3. Then from C to A the value is 2, C to B the cost is 4, C to C it is 0, C to D doesn't have connection, so we take it as 999. Then C to E it is 4. Next from D to A it is 3, D to B doesn't have connection, B to C, D to C we doesn't have connection, D to D it is 0, D to E again it is 999. Then last, E to A no link, E to B 3, E to C 4, E to D no link, E to E it is 0. So I will enter. Now I will select a one node. From here the shortest path to all the nodes is calculated. I will take it as node A. Node A means here it is 0. So I will enter it as a 0. We can see here all the paths with the shortest values are finded, right? From node A, the B it is 5, that is 0, 1 direct connection, direct path. From node A to C it is 3 direct, right? Node D it is 3. Node 5 or node 4 or E, we have different paths. We can go from A to B, then E, A to C, C to B, then E, or A to C, then E. Right? So among all these paths, I select the shortest path, that is from A to C, C to E. Right? So the shortest path is A to C, C to E. Right? So the value of the cost is 6. Same values are present in your output. Right? So this is the end of the video. Thank you very much.